Hi linear algebra students. In this video, I'm going to prove the column pivot theorem. Here it is. If A is a m by n matrix, we're focusing now on n, which is the number of columns, then these three statements are equivalent. Ax equals 0 has only the trivial solution. I forgot my period. The n columns of A are linearly independent. And finally, A has a pivot position in every column. So the way to use this theorem is typically you're going to answer a question about linear independence. You will have a set of vectors and you will ask yourself, are these linearly independent or linearly dependent? And the way to use this theorem is to put the vectors in a matrix A as the columns of a matrix A, row reduce it, and answer question C. Does it have a pivot in every column? If the answer is yes, the vectors are linearly independent. If the answer is no, the vectors are linearly dependent. And you use the theorem in the same way for answering this question. How many solutions does the system Ax equals 0 has, right? So if the answer to this is yes, it has only one solution. If the answer to this is no, then it has many solutions, infinitely many. And before starting the proof, I want to mention that this pretty much corresponds to proving that non-pivot columns correspond to free variables. In my opinion, this makes sense. Like if you reduce a lot of matrix, by experience, you will take that for granted. But it's actually not that easy to prove. Okay? We know that A and B, the first two statements, are equivalent by definition, because the definition of linear independence of vectors is this one. So if this equation has only the trivial solution, if the only weights giving the zero vector are the weights of all zeros, pretty much. So that's the definition of linear independence. And it also comes from the fact that A times X, we define it to be the linear combination of the column vectors of A with the components of X as weights. So that's it. If we know that this has only the trivial solution, then this equation also has the trivial solution. Okay. Having that established, we know this. The proof is going to be separated in two steps. We will first prove that B implies C. So in other words, if B is true, C is true. Okay? Then we will prove that if C is true, A is true. So this will give us what we call an implication loop, in the sense that we can go from one statement to another in any way we want. So meaning that if we know that, for example, this statement is true, we automatically know that all of the statements are true. Let's get going. So let's erase all this. So step number one, okay? So I will put it in brackets here. We want to prove that B implies C, okay? And the way we're going to do it is we will prove actually the reciprocal. We will prove that if C is false, then necessarily B cannot be true. B is also false. Okay, so we prove that if C is false, B can't be true. B is also false. So for those of you that know logic very well, what we're doing is we're proving the reciprocal. We prove the reciprocal. Or, oh, it's the contrapositive. Sorry about that. It's the contrapositive. Okay, so how do we do this? We assume that A has at least one non-pivot column. Okay, so assume that C is false, meaning that A has a non-pivot column. Okay. Suppose that this non-pivot column is AI. Okay, let's just call it AI, and let's take the first of the first non-pivot column. So suppose that the first non-pivot column of A is AI, and which means that A1 all the way up to AI minus 1 are pivot columns. Okay? So what this means is that if we take all the matrices like A1 all the way up to I minus 1 AI. Okay. Yeah, here actually I have to be... Oh, okay, no, let's not even do that. Okay. What it means basically is that the system, so the system or let's just say the equation x1 a1 plus all the way up plus xi minus 1 ai minus 1 equals to ai is consistent. And how do we know this? It's because we know that the augmented matrix with A1, AI minus 1 with AI doesn't have a pivot in its last column. Okay? Okay. So let's take a solution for this equation. So consider the solution C1 A1 plus or C1 all the way up to Ci minus 1, okay? Then in this case, AI, so C1 A1 plus all the way up plus Ci minus 1 AI minus 1 equals AI, okay? Then in this case, it means that we have this, okay? Now what we're going to do is we're going to send AI over. So C1 A1 plus all the way up plus Ci minus 1 AI minus 1. Now minus 1 AI. And then I'm just going to write here plus 0 AI plus 1. Or actually, let's put them in green. Plus 0 AI plus 1. Plus all the way up plus 0 AN. Okay? So here I take all the vectors of A. And then this equals to 0 is a non-trivial solution to AX, like is a linear dependence relation. Is a non-trivial linear dependence relation. Now the non-trivial comes from this, from the fact that the weight of AI is not equal to 0. Okay? So it means that A1 to AN is linearly dependent. So meaning that B is false. And this completes the first part of the proof because C false means that B is false, and hence C true implies that B is true. So that's it. B true implies that C is true. All right, so this part right here is established, okay? This is part number 1. Now let's erase everything and prove that if C is true, then A is true. Okay, this is actually much easier. So if A has a pivot position in every column, so suppose C true, then the RREF of A is, so okay, I'm gonna write here so if we take the augmented matrix and put the 0 vector, what we're gonna get is this. So we perform the reduced row echelon form. And what we're going to get is a bunch of zeros like this. Okay. And what we might have over here are rows of zeros. And then in the coefficient column, we have like 0, 0, and all the way down to 0. So that's how the system looks like, okay? So as a result, So AX equal 0 is equivalent to the system x1 is equal to 0, x2 is equal to 0, all the way up to xn is equal to 0, with as many 0 equals 0 as there are rows of 0. With a 0 equals 0 for every row of 0. And as you can see, this equivalent system is consistent. The 0 over 0 equations can just be ignored. And this is actually the solution, right? It has a unique solution. So this equivalent system has the unique solution so x equal 0, okay? So as a result, A is true. And this completes the full proof. Hopefully this helped. See you in the next video.